Hello, class, and welcome to week 3 of CIS 101, Intro to Computers and Their Uses. This week we'll be covering operating systems and we'll be also covering application software. So two different types of software. There's a system software and application software. And this will kind of introduce some of the more interesting parts of the class where we'll actually be covering internet surfing, productivity software like Word, Excel, PowerPoint, and I'm also hoping to do some other cool things. Still planning it out, but maybe we'll build a website, some no-code websites. So yeah, some interesting things in store in this software unit. But before we get to the actual using the software, it's still important to take a deep dive on the different types of software. And of course, we always have to start with system software or operating systems. A little bit of a review there. Anyway, so computers need instructions on how to operate and perform basic tasks. So to actually use the hardware on the computer, we need software to tell it what to do. This special type of software also has to translate your commands into binary and machine code, so something that the computer can understand. There's definitely steps in between. That's definitely an oversimplification, but that's the general idea. So this week we'll review the differences between system software, the operating system, and application software. That's the software that you use in your daily life. It could be TikTok, that could be Word, that could be Google Chrome. So operating systems. We're gonna do a little bit of review. So what is application software? So software refers to the programs or instructions used to tell the computer what to do. Software applications are typically installed on a computer before they can be used. Commonly used application software includes, like we said, productivity software, internet browsers, social media. So this is kind of software you're usually used to using. And then there's operating system, which is a different type of software. I called it the middleman in the very first week. So this sits in between software and hardware. It helps the hardware uh, play nicely with the software. So the operating system is that layer in between. So it makes sure that everything works together smoothly. So it's a special type of software, often called system software, that manages the interactions between hardware and software resources. Manages all the hardware parts of a computer, including power consumption, processing units, storage, security. So anything that's hardware, the OS is going to tell it what to do. So OS is another way to refer to operating systems. There's a discussion assignment today is why we shouldn't give artificial intelligence control over a computer's operating system. Hopefully, some of the content this week will help clear up some of this discussion, give you something to talk about. The video also goes over a little bit of detail, not so much the whys though. So that'll be up to you. So application software versus system software. So system software, it's general purpose. It manages the resources and processes of the computer. It's written in low-level assembly code. So I actually took a class where I had to write in assembly language. So if you're familiar with Python or Java, if you're not, it's okay. But essentially, one command in Java could be like, um, let's say, age is equal to 10. That's one line in Java. In assembly language code, that's going to be a lot longer to do, especially once you start doing more variables, more assignments. That can be like a page of code versus just a few lines. So assembly code, you're dealing with low level. Low level means closer to binary, as we've discussed in the last week, closer to kind of the more difficult language that the computer interprets. High level means more English, words that humans can understand better. So must meet specific hardware needs, interacts closely with hardware. So yeah, operating system software works with your hardware. We'll see in the next slide that there's still layers in between, but for the most part, kind of the gist of it is OS is in between software, those video games, those apps that you use, and then the hardware, the actual parts of your phone or your computer. So it runs anytime the computer is on. So as soon as you turn the computer on, your operating system kicks in and tells all the pieces what to do. That could be the screen, the power, the fan, and so forth. It works in the background, so users don't really access operating system software. It's not like TikTok where you're pushing buttons. The operating system software works on its own. So it runs independently. It's necessary for the system to function. I talked about this with RAM and ROM, kind of how RAM is short-term memory and ROM is long-term memory, just like in humans. When humans, we have processes that happen automatically. In our bodies, our breathing, you don't have to think about your breathing. It just happens on its own. Your blood pumping through your body. Imagine if you had to think about every single vein in your body to get it to work. That'd be crazy, right? So yeah, there's a lot of processes in your body that happen on their own. The same goes for computers. There's a lot of things that happen on their own that users don't really control, but they're essential for you to do the things you want to. So like if you want to run a mile, right? Your body pumps blood, provides you energy, handles your breathing, your oxygen, your carbon dioxide coming out. Well, the computer also handles all those background processes in order for the computer to do what you want it to do. Um, Very complicated. You don't have to interact with this software. It's already pre-configured so that all you have to do is push a button and it does all those things for you. Application software. So this is the actual software you interact with, software that performs specific tasks, meets your needs, the user. It's written in higher level languages. Like I mentioned, Python is one of them, JavaScript. So these languages are a bit closer to English. They still might seem like another language though, if you've never seen them before. Does not take hardware into account and doesn't not interact directly with hardware. So yeah, it doesn't have to worry about, how much power the app needs, what pixels to put on the screen. That's what the OS takes care of, all the difficult hardware work. So the user usually installs the software whenever you need it. You can add and remove these programs. OS, you do not want to remove your OS because then your computer becomes dead weight. It's just a hunk of metal that doesn't know how to work. So it runs in the foregrounds, and users work directly with the software to perform specific tasks. If you're on Word, you want to write your essay. If you're on TikTok, you just want to swipe through, get some entertaining content. So it needs the system software to run. Without the OS, the application software wouldn't work because all the parts that power your computer on wouldn't be able to work together. So isn't needed for the system to function. You don't need TikTok on your phone to get it to work. You do need your OS, your iOS if you're on iPhone, your Android if you're on pretty much any other device, smartphone device. So software stack. So there's a little bit of extra information here. Notice there's not a star on this slide. You do not need to know this information. But at the bottom we have hardware. In the middle we have OS. And at the top we have our application software. So things that you actually use. Like I said, there are layers in between. There's even optional layers here, a hypervisor, virtual machines if you're familiar. But for the kind of the gist of it, you have your OS in the middle, application software at the top. That's the stuff you interact with. And then the hardware at the bottom. Those are the physical parts of your computer. So let's take a deep dive on operating system. Not too deep, but definitely a little bit more detail than we've gone in the first week. So one of the main jobs of an OS is to translate user input into a form that a computer can understand. Like I've said before, there are extra layers that eventually translate this to binary code. So it's not the OS directly doing the translation. There are layers to it, but it does play a crucial part in translating your input down into that machine code. So the first job of the OS is to boot, aka start up your computer whenever it powers on. So the OS will launch many startup programs. So just like I said with the body, right? The body has your oxygen, your lungs, your blood pumping. Whenever you want to move a muscle, right? Tons of muscle tissues move to get your arm to flex or your leg to extend, right? It's the same for computers. There's a lot of little programs that start up that make it possible for you to do all the cool stuff that you do on the computer, whether it be your smartphone, your tablet, your laptop or desktop. So these features include like the display, file systems, right, where you save your data, and even security services, things that keep your information secure. That's just as important as everything else on the computer. So many of the important processes run in the background, meaning you don't really interact with these. They're always on. They're always working to get the computer to function correctly. If your OS is messed up, your computer will be messed up. But they run in the background, meaning you don't really interact with them, and they're kind of just always on when the computer is on. So OS and hardware. Here you can see something some of you might be familiar. If you're on Windows, the Task Manager. So the Task Manager, I can actually pull it up. Let's see. So Control Alt Delete on my keyboard, and then I pull up the Task Manager. And here it is. Here's my Task Manager. So I have my recording software here running. So this is my application software. I have Chrome where you can see my slides, Visual Studio Code. I was coding for my other job. And then I have Zoom, which I use to also record these videos. And then I have 175 background processes. So I didn't start these up. These started on their own. Some of these I could probably cut these off. So for example, like Edge, this probably doesn't need to be running. So if I end the task, it ends a few different background tasks. It was probably on because I had it on at some point and it triggered a few other tasks. Some of these I don't want to end because they would definitely mess things up. They might make my computer crash. In fact, if I try to end one of these, no, I'm not even going to try to do it because I'm scared of what's going to happen. So yeah, I'm sure if you restart your computer, everything would be fine. But yeah, as you can see, ton of background processes, some more important than others. I can see an anti-malware core service. So this is preventing like security breaches from happening, from reaching my computer. So all kinds of different functions here. A lot of them that I don't really know what they do. I don't really interact with them if I'm being honest. But they're always running. They're making my computer work appropriately. But the actual software that I use, there's only 6 of them running. I can close one of those and nothing's going to happen to my computer versus these background ones might be a lot more important. Let's go ahead and go back to our slides. All right, so yeah, here, a little screenshot from when I was running my computer earlier. And then you can see email, right? So these are my software, application software, and this is my system software running in the background. So just a little video. This is of the DOS system. I really just want you to watch the introduction section. Let me go ahead and pause that. So just go ahead and watch the introduction, and then go ahead and watch the final part, the MS-DOS. The middle, I do encourage you to watch it as well. You don't have to. It goes through the different tasks that an operating system will handle. We'll definitely cover some of these in the slides. So if you do want more details, some more visuals, definitely invite you to watch that. But yeah, go ahead and watch the introduction, just 2 minutes, and then watch that end from about minute 11 all the way to the end, so about another 2 minutes. Goes over one of the early operating systems for personal computers, DOS, which was Disk Operating System. So go ahead and watch that. You can pause the video and then go to the next one on the playlist. Yeah, so it's always on the YouTube playlist if you're curious, the videos that we watch here on the slides. Or you can always go to the module section of the class and watch that video. So go ahead and watch that video. You can pause on this one, watch the other one. All right, so DOS. So you took a quick look at DOS, one of the early operating systems. It was actually the most popular when it came out. So use a command line interface. It was created by Microsoft, so that is Bill Gates. This is how he became a billionaire, through his operating system. It obviously had many iterations, right? Microsoft has had many versions. The first one was DOS. Actually, here on the right, somebody had an interesting project. So ChatGPT, you can actually use a ChatGPT client, meaning you can get ChatGPT like a small instance of it, a small snapshot, and put it into your own programs if you're a developer, if you're a programmer, or software engineer, such as myself. Well, someone who wanted to have some fun with it decided to put ChatGPT on the DOS operating system. So this is actually what it would look like. So it is running a very complicated software, but on a very, very old interface. So interface is how you interact with the computer. this is called command line, meaning that there's no pictures, there's no buttons. It's all commands. Um, so yeah, the only way you could communicate with the DOS system was by writing different commands. So you had to have a guide of which commands to send in. Not the easiest to use, but was still better than previous iterations of computers. So now it's considered obsolete, right? DOS is, we definitely don't use it today. However, if you go here, if you go on your search on Windows, I know you can't see it, but if you type in command prompt, a lot of the same commands here on the Windows command prompt. Command prompt is just like another command line interface that you can still use today. Uh, this is actually what DOS was. A lot of the same commands you can still use here on the command prompt on modern day Windows computers. So let's see, ls, it's dir, and different command prompts, different commands. But dir is for the directory. It tells me all the different folders in my current directory. cd, I can open one of these. So let's do cd. I don't know. Let's go pictures, and then let's go directory. And these are all the pictures in this directory. So it's the same if I had gone into this folder, right, and then gone pictures and then gone to here. I can do that through command line. So everything was possible through command line. It's way easier though. I think all of us would agree to have these nice little buttons to navigate. But it is possible to do everything via command line. I'm actually teaching a class on Linux, which is a different operating system. We'll briefly talk about that one in one of the slides. And that class is all about commands to run on Linux. So it's still useful to know command line, especially if you're a developer, if you're making programs, if you're making software. But for us users of software, not so useful, not so important to know command line. All right, so OS and processing techniques. As we saw with DOS, the disk operating system, very early operating system, it's important for computers to be able to execute multiple tasks. So if you watched the video, you saw that DOS would constantly crash. So you couldn't really run multiple programs at once. Nowadays, if you're on your phone, you might be, you might have the GPS on and your Spotify playing. You might be watching YouTube and also surfing the web. Um, on your computer, you might have, 5 different windows open, 100 tabs. So multitasking is super important in computers. There's actually special techniques that operating systems will employ so that even though they're limited in their resources, right? We only have so much RAM, only so much resources, only so much memory, power, storage, all those things. Well, computers operate on these special techniques that they found make it possible for us to do all the cool things we want to do and do multiple of those things at the same time. So here are some of the techniques. We got multitasking, multi-threading. We'll only be covering a few of these. There's more that I haven't included. It definitely gets very complicated with how CPUs and OS work together to solve the problem of doing multiple tasks. As you can see, the little octopus doing many things at once is the icon I chose. So first is multitasking. So multitasking refers to the ability of an operating system to have more than one program, also called the task. So program, you call it task. Anything that's a software giving instructions to the computer, it's even called a job. So it's whatever the operating system has to do, has to solve. We call it a task. So when you have more than one task open at a time, that's called multitasking. So you can write a Word document in one window while also surfing the web in another. For most of us, we might be doing like 10 things at once, right, on our computer, especially if, we have an assignment due the next day. So single CPU can only execute one task at a time. Crazy, right? So we think of this CPU as super powerful. Our computers have super advanced CPUs. Um, they only have one though for the most part. Now, as we'll see, that a CPU can have multiple smaller CPUs inside called cores. We'll cover that in the next slides. So how is it possible that a CPU can only execute one task at a time, yet our CPU is doing, on my computer alone, it's recording, it's putting my face with Zoom, right? Putting my face on the video. Um, I'm also at the same time, right? It's giving me audio. I have my Visual Studio Code, my coding software open. I'm also surfing the web at the same time, right? I'm flipping through these slides. And I have two monitors open at the same time. How's it doing everything at once if it can only execute one task at a time? Well, this is multitasking. How is it made possible? Well, it helps if you can switch between tasks so quickly that it appears to the user that all programs are executing at the same time. So the truth is, like I said, there's going to be more than one CPU. Even in a computer with one CPU, there's actually more than one. There's smaller ones inside. But it turns out multitasking for computers, they can actually switch super quickly between tasks. So when you're opening a tab and then opening another one, and switching between tabs, it might seem like you have both tabs running, both tabs open. The truth is your CPU might be switching back and forth between the different tasks. It does it so quickly that to your eye, it seems like both of them are running at once. But the truth is that each of those programs are feeding instructions. And those instructions aren't, constant. There's time in between each instruction. Even when you're playing a video, right? The instructions don't come in all at the same time. So the computer will execute one task, come back to the other, come back to the other. If it does it quickly enough, it seems like it's doing two at the same time. But yeah, the question is, what if you do have more than one CPU? Couldn't you do more tasks? Well, the truth is yes. That's called multiprocessing. So multiprocessing is when you have more than one CPU helping you solve these tasks. So like I said, the truth is, even though your computer might have one CPU, it has multiple cores. So a lot of computers, for example, could have 8 cores in one CPU. That means 8 different little CPUs inside your big CPU. So multiprocessing is when those CPUs all work together, either on a different task, so that's multiprocessing. Now, if multiple CPUs work on the same task, we call that parallel processing. But the idea is the same. You're recruiting multiple CPUs to help you solve the job. It's always easier, right, to solve those tasks of multitasking if you have more workers to solve those problems, to do those jobs. So multiprocessing is common in PCs today, as many have multi-core CPUs. So even if there's one CPU, there's going to be multiple mini CPUs or cores. As you can see here, core is a mini processor or CPU inside the main CPU. Yeah, so I said CPU a lot of times, but it's just because, you know, in computers, we used to distinguish between that main CPU and the smaller ones, which are cores. So types of operating systems. Well, every type of computer has a type of operating system. Personal computers have personal operating systems, also called desktop operating systems. Server operating systems are for server computers, also called network operating system. Your phones, those have mobile operating systems. And then for your microwaves, right, your remote controls, um, your microphones, that's going to be embedded operating systems for embedded computers. So different operating systems solving different jobs. And that's because they have different hardware as well, right? So if you're going to be interacting with different hardware, you're going to need a different operating system. Yeah, like your smartphone and your computer, totally different hardware. All right, so memory. So this is another technique for solving the problem of processing multiple things at once. So many programs today are memory intensive. So managing the limited memory resources in a computer is important for efficient processing. You only have so much RAM on your computer. So when you're playing a video game, right, and your video game has like very intense graphics, so a lot of images, a lot of 3D assets, it's going to put a lot of work on the RAM, a lot of work on your computer. That short-term memory, right, that solves those quick tasks. Well, it turns out the computer can employ certain tricks so that it appears like it has more RAM. Um, Something to note is when you are running all these multiple tasks, right? It is a good idea that when you want to save your computer some work, you close the programs when you no longer need them. So if we go back to that task manager, notice this memory right here. Like I said, memory, most people talk about it as far as your RAM. So when we're saying the word memory, we're often referring to RAM. And it also has our CPU usage here. So how much of the CPU of our cores And yeah, you can see right there, it says total. Let me hover over that. Total processor utilization across all cores, across all the mini CPUs. So far, I'm only using 20% of my CPU, of my little CPUs, my little army of CPUs. My memory, though, is 37%. And I can see here that Google is using a lot of that memory, most of it. If I open more programs, that CPU is going to go higher and higher. So if you ever hear your computer getting very, very hot, it's because it's processing a lot of tasks. It's handling a lot of data. So if you want to save your computer some of that work, some of those jobs, go ahead and close the programs when you don't need them. So for example, I have Windows Explorer open. I'm going to go ahead and close that. It's going to save my computer a little bit of memory. Now that one wasn't using much, so it's not going to make much of an impact. If I close my Google Chrome though, that's going to make a huge impact on my memory usage and probably give my computer a break. So yeah, whenever you hear that fan rumbling, it's probably because you're using way too much RAM on your computer. All right, so what's a trick for a computer to extend its RAM, extend its memory? Virtual memory. So virtual memory is a memory system used by an OS to extend the computer's physical memory. So RAM is its limit. But there are other storage systems, like we talked about, the ROM, right, or the auxiliary storage. So by leaning on the hard drive or the solid state drive, the SSD, so other memory hardware, you can use that hardware in place of the RAM. So you can pretend like it's a RAM where you put data in there and then take it out very quickly, right? So that's called virtual memory, an important one to know in terms of not just multitasking, but also just how operating systems solve the problem of limited resources. So yeah, virtual memory is a trick that computers will use to extend their power. All right, so let's talk operating systems. So here, two of the biggest personal computer operating systems that are here today. They were there when operating systems first started, so they've stuck around since the beginning in the history of personal computers. There's one clear winner, and that's Windows. It's used by 70% of PCs, whereas Mac OS is only used by 15%. So Mac is the Apple competitor. Of devices and operating systems. Windows 1.0, that was released right after DOS. So it's called MS-DOS, so Microsoft Disk Operating System. They wanted a graphical interface, so command line interface was kind of hard to use. We wanted buttons, we wanted pictures, we wanted icons, things that humans, right, can understand a lot more easily than memorizing a dictionary of commands. Well, that's when Windows 1.0 was released, and it came with a graphical user interface. It had buttons and icons. It turns out it was not popular though because of competition, Apple's Macintosh. So yeah, the first OS from Apple was actually kicking Windows butt. So in the back in the history of operating systems, um, Mac OS was actually a winner at some point. It's called Windows because it allows multiple applications to run in separate windows. And if you notice the logo for Windows, they are indeed resembling a window. Um, and yeah, if you've seen some of the backgrounds for Windows, you'll actually I might even like put it in our this week's module just as like a fun little resource. Yeah, some of the pictures they use for their logos, they're actually recreating a window. They're throwing light through a window to make the logo. Anyways, not super important. Now let's go to Mac OS. So it was the first commercially available GUI-based operating system. So it had a graphical user interface, had pictures, buttons, icons, way easier to use than command line. Mac or Macintosh, the name came from an apple, the Macintosh apple, which was known for its crispness and flavor. So one of the employees thought it was a good name. And yeah, it fits the entire right logo and aesthetic of Apple products. So other operating systems. So it's not just Windows and Mac OS. There are other ones. One of the big ones is Linux, which is my CIS 112 class. We'll be using the Linux operating system and using commands for Linux. For my day to day, we actually use Linux a lot. Even though I'm on a Windows computer, I can spin up what's called a virtual machine. So kind of like my computer almost has like a baby machine, right? A baby computer. And I can pick which operating system I want on that computer. Linux is one example. Some of these other ones are actually built off of Linux. Red Hat, Fedora. Those are people got together. They said, "Oh, I want to make my custom Linux operating system," and they came up with these. You can see some other ones. Arch Linux, Ubuntu is another. Debian, another one, and a bunch of other ones that I don't even recognize. So mobile operating systems, some that most of you will be really familiar with, especially some of our younger students. So Apple iOS, it's used by 70. Oh, I think I have this swapped. I need to fix this. So it's actually the other way around, I think. Yeah, I need to fix these slides. So Google Android should be around roughly, I believe, yeah, 70%. So I think these percentages are switched. I'll put out an announcement for that edit because I want to make sure you guys have the right information. So let's see. So yeah, these percentages are off, but globally, Android is used way more than Apple. I have to tell you that. Here in the US, iOS might be the winner, but globally, Android is actually the winner. I usually attest this to cost effectiveness. Android phones tend to be not as expensive, so globally, you'll usually see Android more than iOS. So the first iOS, Apple OS system for iPhone was introduced with the original iPhone in 2007. So helped, interact with that new capacitive touchscreen as we saw in last week's video. It also introduced the App Store the very next year, so that revolutionized the mobile app industry. People could develop, add their own products to the to the App Store, and then people could download those, right? For free or for a small cost. Siri was introduced in 2011 in iOS 5. So as when you get those updates, they are making updates, right, to their system. So the Android operating system from Google. So it's founded in 2003. So it wasn't first started by Google, but Google bought it in 2005 once they saw that it was picking up some speed and had a lot of promise. So it was made by a group of developers that got bought out by Google. So the first Android smartphone, so the first use of the Android OS was on the HTC Dream in 2008. So only a year after the iPhone. The Google Play Store was released a few months after Apple's App Store, so it was a competitor to Apple iOS. So two different options. They essentially do the same thing.